Hey guys, welcome back to my YouTube channel. So in this lecture, we are going to see one of the very important problem on the propagation delay. So last class we discussed on hazards, right? So if you guys able to understand this problem, then you can able to understand how the physical idea or how the physical significance of delay will act in a circuit. How much important is to reduce the delay to 0 milliseconds. So let me check it and let me solve this problem. So if you guys able to have understanding and you can solve this problem, please pause the video and try to solve it. So if not, also not an issue. So let me solve it. So here is a Vi which is changing abruptly from 0 to 1 at t naught. So t naught is the time at which V nil changes, where G1 has the delay of 10 nanoseconds and G2 has a delay of 20 nanoseconds. So this is an XOR gate and this is an NAND gate, single input NOR gate. Okay. So let me draw a curve here. So it will be helpful for you to trace everything in a single line. So this is input graph. So here I am pointing out one more thing, that is Vi dash. So this is an intermediate output. So this is for Vi dash. Okay. So this is for Vi dash. So this is for V naught. And this is for actual V naught. So I will let you know what's the difference here. So I will let you know. Please stay tuned, guys. Okay. So let's take the case. This is Vi, right? So Vi is abruptly changing at this level. So I'm taking blue color here. So Va is 0 up to this level, and which is abruptly changing at this particular time, which is t naught. So after t naught, which is abruptly changing to 1. So that is what the condition we have. So this timing is t naught. So this timing is t naught. Okay. So let's take a thing that is Vi dash. So how the Vi dash graph will look here, it will be. So Vi graph here will be the this section, it will act like a NOR gate. So the both the input are same. So input will be toggled to the opposite case. So here it is changing from 0 to 1. So it will change to 1 to 0. So if you see, it will go down. So it is already, it is 0. So the output will be stayed up to 1. So why I am mentioning this delay? Because at the t naught it need to show, but the G1 has a 10 millisecond of delay. So that's why I am shifting this to 10 millisecond and then drawing the graph like this. Okay, so I hope you guys able to understand, right? So let me mark. So this is this point, which is t naught plus 10 nanoseconds. So this much delay. So this is the 10 nanoseconds delay. So because of this, the output will change only after 10 nanosecond. So this is G1 output. So G1 output. So G2 is just an XOR of both things. So we know that when both the thing are in opposite bit, the output will be 1. So up to this condition, up to this one, this T naught, the output will be, so I'm drawing the exact V naught. So which is V naught without delay, no delay. So no delay I'm drawing. Okay, so here that is 0 and 1. So output will be 1. So up to this level, output will be 1. So that's I'm drawing here. So up to this level, output will be 1. So in this level, both are 1. So output will be changed to 0 here, right? So it will be 0 up to, it will maintain up to here. After this, it is 1, this is 0. So then it will again turn back to 1. So this will be the actual condition that need to be there without any considering any delay. But we know this has a 20 second of delay. So we need to shift this graph to 20 second to outside. So that is completely out to that side. So that is what we need to check here. So if we note the point, so this is T naught. So which is T naught. So I'm mentioning the above. So which is T naught. So let's take this as a T1. Okay. So if we write actual V naught, this is the actual with the delay. So with the delay, this need to be shifted to 20 millisecond. So that's what. So this will prolong stay up to 20 millisecond, like a 20 milliseconds of delay. So let's take this is the case. Then it will come down here for the small dip of time, and then it will again go to up, and it will sustain. Okay, so I hope you guys able to understand, right? So there is some difference. So this condition we can state as T naught plus 20 milliseconds. Okay, so this is what the case. So this one can represent as T1 plus 20 millisecond, 20 nanoseconds. Okay, so this is how the final graph. So the last one mentioning here, right? So this will be the output V naught. So this is the actual output. So that we have to choose here. So I hope you guys able to understand, right? So even the small delay, we will be expect the system to react here itself. So like this way, but here you see there will be a delay of 20 nanoseconds, 20 nanoseconds. Even actually I mentioned it very very nearby, but this distance, the distance between this need to be 20 difference need to be 20 nanosecond from this point to this point, not from here. So this point to be 20 nanosecond. So that's why I mentioned T naught plus 20 nanoseconds. So okay, so because I am mentioning this one as a T naught, so from this one the output will take that much time to react to the outside. So I hope this is able, you can able to understand this concept. So this is a small thing only. So whenever the input change at a time is T naught, because of the first gate put delay, so this get reflected 10 nanosecond delay. So this output is continuously available here. So this is with the 10 nanosecond delay only. So this is the actual output, but this one has a 20 nanosecond of output delay, right? So we have shifted this just to 20 nanosecond. So T0 plus 20, T1 plus 20. Okay, so that is what the actual output. So nothing to confuse. So this is very understood, right? So from this we can concluding our discussion on all the concept of gate and all the concept with the delay everything. So next we are going to discuss one of the important thing, that is SOP, POS, Minterm, Maxterm. So for K-map understanding purpose, these are very much needed. So if you guys already have an idea, please get over it, so you guys be able to understand more thing. If you guys didn't have any ideas, so this is not a problem, so we can look over it. So SOP is nothing but sum of products. So this is normal mathematical definition only, nothing to be different. This is product of sum. Okay. So in SOP is the way of representing a function. So is a way of, it's a way of representing the function with the help of Minterms. The way of representing output with ones, that is termed as Minterm. So that we will be representing with the one. So I will explain this more clearly once in the output. Output that is termed as Minterm. So product of sum. So it is the same. It is a way of representing. It's a way of representing the function with the help of zeros in the output. So we are the same function that can be represented in two ways. That is one with a minterm and another one is a maxterm. So where minterm has all this output as 1, where maxterm has all its output as 0. So that is what the case that we are going to discuss. So for now, just to understand this definition. So once we saw the more problems related to this, we can able to understand. So let me draw a truth table so that you can able to understand it. So okay, so this will be with it's the same function that can be written in both the two different ways. So that is one with the minterms, another one is maxterm. So let's take the case which is A and B. So this is minterms, and this is maxterms. So it is 0, 0, 0, 1, 1, 0, 1, 1. Okay. So we know that it is 2. The minterm will has all its output in zeros. Sorry, minterm has all its output in the ones. So then what we have to do is that we have to make this 0 as 1. So then we can represent this as A bar, B bar. So as we representing this with the 1, so we can directly make this a dot product. Okay, so this can be written as A bar dot B, because B is already 1. Okay, so this is A dot B bar. So this is AB. So all this output will be equal to 1. Here you can see any of the term, it can this term can the in min term whatever may be the input, if that is presented, the output will be always 1. So that is what the idea here. Max term can be written in terms of 0 as we state here, which is with 0, and this is product of sums. So here we have to add a plus b because both are already 0. The 1 need to be changed to 0. So a plus b bar. So here a is already 1, so a bar plus b. So here both need to be changed. So a bar plus b bar. Okay, so this way it will always give 1. It will always give 0. That will always give 1. It always gives 0. It will give 0 only for 0 comma 0. So the thing is that if we add both the number without the normal thing, so we haven't done here, so this will always be output. So we have made a change that always this output will be equal to 0. So this will always output will be 1. So that's what the changes that we have done here. So for an example, how this can be represented, how these things can be represented is that, so let's take a function. So let's take a function. If the function output is 0 at this value, when 0 0 is given as input, output is 0. When 0 1 is given, output is 1, and 1 0 output is 1, and 1 is 0 output is 0. So this is an truth table of XOR gate, right? So this is a truth table of XOR gate I have written. So the y, instead of y I am mentioning that as a function. So that is what thing. So how this can be written in minterm and maxterm is that this can be written in a format like this. So this can be, this f can be written as, this one we can name as m0, m1, m2, m3 as a min term. As it is a max term, so use capital. So m0, m1, m2, m3. So this function can be written as a summation of m1 plus m2 because this we are representing with min term, right? So min term is sum of product. So this is individual product and this is sum. So this is SOP. So this is what sum of product. This is sum, SOP sum, and this dot is a product. The max term which can be represented as the function that can be represented as, this can also be written as summation of m1 comma 2 because m1 m2 that we are written like this. So this one can be written as the product of m0 dot m3. So which is as the product of the capital M 0 comma 3. Here if you see, we have took only 1. The min term is only with the 1. The output 1 and 2 are taken, 1 and 2. But the max term is where we will take only output as 0. So 0 and m3. So that is what the quite difference between min term and max term. So the same function can be represented in two logics. So this is first logic, this is second logic. So that is what the advantage that we are taking. So why we are choosing min term for SOP and max term for POS is that only one condition this output will be 0, that is 0 comma 0. So whenever the output will any one is 0, so even any one of the output is 0, the output will be considered 0. So that is why we take product here. Here even if any one of the input is 1, then output will be 1. So that is why we consider SOP here. So that is what the quite difference between SOP and POS. So SOP is one kind of representation and POS is one kind of representation, but that is for a same function. We can choose anything based upon our understanding. So I hope this is understood for you guys. So in next lecture we will know how we can map this to a K-map. So I will be explaining that for next class. So stay tuned guys, like, share and subscribe our channel. I hope this is understood for you guys. Please give a valuable comments in the feedback.